Kia ora koutou. My name is Gaya Gnanalingam and I'm a marine ecologist based at the University of Otago. And we've been looking at some of the effects of the marine heatwave, or thermal stress in particular, on New Zealand rock lobster. And this is a figure you've just seen in Rob's talk, and I'm glad that Rob spoke before me because it means that I don't have to try and pretend like I know much about the oceanographic conditions around southern New Zealand. But basically, the 2022 marine heatwave was the impetus for this research. Early in 2022, we received a call from Rebecca McLeod that led on to a call to Malcolm Lawson, basically to inform us that there were some concerns about rock lobster that were being caught in the Fiordland area and their condition. They were being described as somewhat poorly, lethargic and floppy. And as a demonstration, this is what a floppy crayfish looks like. So for those of you that are familiar with rock lobsters or crayfish, you know if you pick them up, normally they would be flapping like crazy as soon as you try and handle them. And so obviously there were some concerns around the condition of these lobsters and whether this poor condition was associated with these marine heatwave events that the area had been experiencing both in 2022 and then more recently in 2023. As many of you no doubt know, rock lobsters are one of our most valuable fisheries. And significantly the Cray 8 area, which runs from, Westland all the way around to Rakiura, is the most economically valuable. Rock lobsters, of course, are also an important customary fishery as well as a recreational fishery as well. So, obviously poorly lobsters are an important issue. So our research objectives, we were lucky enough to get a little bit of funding from the University of Otago to basically do a little bit of a preliminary study on thermal stress on rock lobsters. So our two questions were to assess how elevated temperatures affected their physiology and survival, and to assess if potential declines related to these elevated temperatures could be reversed. So basically, once the temperature comes down, will they recover? And so we started the work with a little bit of a field assessment. We went over to Jackson Bay and surveyed some of the lobsters that were being caught there. So that's where the footage of the floppy lobster came from. We were lucky enough to jump on a boat there. Paul Egling was very kind enough to take us out, and we sampled some of the lobsters there. We did some just standard assessments, weighed, measured, and we took some blood samples which we then took back to the lab to assess some of the biochemical properties of the blood and just get some assessment of their nutritional condition. We followed this with a lab assessment based at the Portobello Marine Lab in Dunedin, and this is where we basically simulated a marine heatwave. We took adult lobsters from the Cray 8 area, and after a period of acclimation, we subjected them to a marine heatwave. Now, the heatwave was based on the conditions that were observed in Jackson Bay in 2022. So basically, we ramped them up for about a month. So that was the peak of the heatwave, and then gave them 2 months to recover. Now, throughout these the heatwave, we did a number of sampling events. So we tested their blood, we did some general stress indicators, and we did some respirometry. And I'll go through those methods in a little bit more detail. We also had 3 different temperature treatments. So the red line indicates the sort of extreme marine heatwave conditions. So at the peak, it was at 22 degrees. We then also had a strong marine heatwave. So the peak there was 19.5, and then we also had some control animals that were kept at 17 degrees. So these were the metrics that we assessed. We did some blood sampling, so basically if you stick a syringe into the 5th walking leg, you can extract blood. It doesn't seem to bother them, and so we did that multiple times through the heatwave and looked at the blood refractive index, which is just a measure of nutritional condition, as well as sent blood samples off to check for metabolites. We then also did some respirometry. So respirometry is where you basically test oxygen metabolism. So the animal gets placed into a chamber. It has a flush cycle where water gets pumped through the chamber, and then a closed cycle where no more seawater is added. So then you can basically assess how oxygen is used during that time. We spent nights out at the Portobello Marine Lab, basically having to check the animal every hour through the night. Great experience, I can really recommend it. And then finally, those general stress indicators were based on a study by McDermott and Stewart in 2014, and it's the sort of visual assessment that a fisherman would do, basically. So to look at things like tail strength or leg strength, how the antennae are held up, just a basic visual assessment, and we did this again quite frequently through the heatwave and recovery period. In terms of some of what we found, so the Haast field sampling, we found for a start that all the individuals that we surveyed were in their intermoult condition, so they weren't getting ready to molt or they weren't post-molt, which is what you'd expect for that time of the year. The reason why this is perhaps a little significant is that there have been studies in South Australia, around Tasmania, where they've shown that the marine heat waves are potentially affecting their molt behaviour. So they might be molting twice a year or later in the year. So the fact that we observed these all in intermoult at that time, I guess, was a positive thing. We also had a look at their blood protein index to look at nutritional condition. Again, no differences between healthy and poorly lobsters. And the blood chemistry results so far also indicated no difference between these two groups of animals. In terms of the experiment, however, we found that the blood protein index did vary with individuals in that high treatment, so in the extreme marine heatwave, having lower values at the peak of the heatwave, but then no difference towards the end. So I guess when things were ramping up, their nutritional condition sort of seemed to decline. And similarly, in terms of metabolites, which are an indicator of stress response, again, at the peak of the heatwave for those extreme marine heatwave animals, they had significantly higher numbers of carnitines and acylcarnitines. And these are believed to regulate nutrient metabolism, so like an anti-stress response. At the end of the heatwave, though, these metabolites weren't observed, and there was no difference between the three groups. In terms of those general stress indicators, so the body position and how they looked visually, what you can see is that, so basically the higher the score, the worse the lobster is. So as the weeks went on, and you can see where the peak of the marine heatwave is around week 10, you can see that for the high group, the average general stress indicator score increased. So they weren't doing so well as the temperature increased. But then as the temperature started to come back down, all those three treatment groups basically bunched up again, so there weren't any real differences in those visual scores. I'm putting up this table again to remind you of what we were looking at, but to point out the general scoring at the top right-hand part of the slide there, which means a cumulative score to sort of give you a general understanding of whether an animal might be exported or not, whether it might be kept for the local market, or whether it would be rejected. So a score of 13 plus would mean that animal would generally be rejected. And what we found was that these scores varied through the marine heatwave, in particular that extreme heatwave, the high group there at the peak. Those scores were really high, so 49% of the animals were deemed exportable. So they weren't in great condition, but by the end of the marine heatwave, that had sort of basically recovered to 84%. So it was sort of suggesting that there was some recovery after the 2 months. And just some general, I guess, other parameters that we looked at. So mortality overall was pretty low. We only lost a couple of individuals through the experiment. There weren't any significant differences in weight, so basically the animals continued to feed as you would expect. And there weren't any differences in their hepatopancreas, so that rather gruesome picture down the bottom there is the inside of a rock lobster, and we have a look at their hepatic pancreas, the pink blobs, basically to, again, assess nutritional condition, and again, there weren't any differences between the treatment groups. So, just to quickly summarise, in terms of the field assessment, no significant differences between what was deemed healthy and poorly. It's got two little stars there because the caveat to that is we were the ones basically determining what was healthy and what was poorly based on, I guess, how floppy they were. It was fairly subjective, and so those differences might not be observable because essentially all of those animals might have really been poorly, or they might have been on the verge of healthy. So it's a bit tricky, and we're doing a little bit more work on the blood chemistry to see if we can tease apart some of those differences, tying them to the experiment. In terms of the lab experiment, the blood chemistry and the general stress indicators suggest some negative effects of elevated temperatures, but that there might also be some recovery. And so this study was a first look, and we're very much interested in taking this research further, obviously with the value of this fishery and the potential for more marine heatwave events in the future. Sort of understanding this in greater detail is a little bit of a priority, and so we're going to look at some key life stages, so things like juveniles in the post-larval stage, as well as some of the processes like reproduction and molting. And with that, a few acknowledgements. In particular, I'd like to acknowledge the Cray 8 Rock Lobster Association, who we've been collaborating with on this research. It's a new sort of collaboration for us, and one that's been, I guess, really valuable, and they've been really helpful. So, thank you. Reproduction and molting. And with that, a few acknowledgements. In particular, I'd like to acknowledge the Cray 8 Rock Lobster Association, who we've been collaborating with on this research. It's a new sort of collaboration for us, and one that's been, I guess, really valuable, and they've been really helpful. So, thank you.